Okay, today we're talking about solving systems of equations by elimination. Our question is, how do I do that? How do I solve a system of equations using elimination? Now, elimination means that we cancel something. System of equations mean that we have two equations with two variables in the cases that we're doing. So there are some steps for solving systems of equations by elimination. The first one is we have to rearrange the equation into standard form. That is that ax plus by equals c. This is different because for graphing we wanted it in slope-intercept form, so make sure that you put it in standard form. The next thing is that if necessary, we multiply one or both the equations by a constant, so at least one pair of like terms has opposite coefficients. We add the equations to eliminate one of the variables and solve for the remaining variable. So if we eliminate the x, we solve for y and vice versa. Then we substitute the value of that variable, the one that we found right there, back into one of the original equations and solve for the other variable. Then we write the steps for 3 and 4, where we solve for these two things as an ordered pair, and we check our work. Sometimes the steps don't make sense until we go through a process a couple times, but you'll see, and I'll refer back to these as we go through them. So let's start with step 1. Look at these equations. Are they in standard form? Neither one of them are in standard form. So we're going to start with the top one over here, negative 28x equals negative 14y minus 14. I'm going to add 14y to both sides so that I get negative 28x plus 14y equals negative 14. So now that equation is in standard form. Let's look at the other one. 11 minus 7x equals negative 2y. Again, not in standard form. So the first thing I'm going to do is move the constant to the other side. Negative 7x equals negative 2y minus 11. Now I'm going to add the y to both sides, so I get negative 7x plus 2y equals negative 11. So now I have my two equations that are in standard form. So all of that was step 1, making sure that they are in standard form. The second one says that if necessary, I have to multiply so that I have opposite coefficients. So we'll start by writing our equation. So we've got negative 28x plus 14y equals negative 14, and negative 7x plus 2y equals negative 11. I don't have two equations, or a variable with with the same coefficient, just opposite. So I have to multiply the bottom equation by 4, negative 4, to be able to do that. So it says, rewrite them, we've done that. Now look at the equations. Are there any equal and opposite variables? So they have to have the same number, opposite signs. And we've already said that 28 and 7 and 14 and 2 don't meet that. So then the answer is no. So I have to come over here and rewrite negative 28x plus 14y equals negative 14. But the other one I changed. So negative 4 and negative 7 is positive 28x minus 8y equals positive 44. So now I have, so that I have equal and opposite. When I add them together, I get 0x plus 6y equals 30. Now I solve the equation in step 3. So now we're going back up here for number 3. We are solving for the remaining variable. So I have 6y equals 30. Y is 5. Now, step 4 says that we substitute this value into one of the equations that we have. I go back and use the original equation from the problems up here, just because there's less chance of a mistake using the original equation. So negative 28x equals negative 14 times 5 minus 14. Negative 28x equals negative 70 minus 14. Negative 28x equals negative 84. Divide by negative 28. And I get that x is 3. So I had x and y. So my coordinate should be 3, 5. This should be my solution. But I need to check. So I have negative 28 times 3 equals negative 14 times 5 minus 14. I need to verify that that's the same thing. And then the other side of that is to say that negative 7 times 3 plus 2 times 5 equals negative 11. So this one is negative 21 plus 10 equals negative 11. It does. And this one is negative 84 equals negative 84. And it does. So that's how I know that my solution is valid. This point, will be on both lines when it's graphed. It'll be where they intersect which makes it b on both lines. Okay, let's go through a couple more examples. Make sure that we're all comfortable with this. So we start by looking for a pair of opposite but same coefficients. And then we add our equations together. They're already in, for step one, they're already in standard form, and they're already have opposite coefficients, -8 and +8x. So that when I combine, those cancel. -4 plus a -1 is -5y, and -28 plus 3 becomes -25. So y is 5. So that is step 3, where we solve for one variable. Now we're going to substitute that back in for step 4. If y is 5, then we take one equation. It doesn't matter which one. And I have 8x minus 5 is 3. Remember that 5 comes from there. I took this equation. So then add 5 to both sides. So I have 8x equals 8, x is 1. So now my solution is the point 1, 5. And I need to check that to verify. -8 times 1 minus 4 times 5 equals -28. 8 times 1 minus 5 equals 3. Both of those are true, and so I can be confident that my solution is correct. Okay, number 2. Starting with, are they both in standard form? This one is, but this first equation is not, so I have to fix that. So 2y equals 2x plus 14. Subtract 2x from both sides. -2x plus 2y equals 14. Now I'm going to combine these two equations. So that's -x minus 2y equals 13, and I'm going to add them together. -2x plus a -x is -3x. -2 and plus 2 is 0 equals 27. So x is -9. So again, we've done step 1 where we wrote them in standard form. Step 2 where we found variables that were the same either because they were already there or because we had to create them. And step 3, we've solved for one of the variables. So now we take that one and substitute it back in so that 2y equals 2 times -9 plus 14. 2y equals -18 plus 14. 2y equals -4. Y equals -2. So my solution should be -9, -2. And the way that we verify that is by saying our check, 2 times -9 equals 2. No, I got my variables backwards. Y is -2 equals 2 times negative 9 plus 14, and negative 9, because remember x is negative 9, so I have to put another one there, minus 2 times negative 2 is 13. So this is negative 4. Negative 18 plus 14 is negative 4. That's true. This is positive 9 plus 4. That's 13. That's true. That's how I know that my solution is correct. All right, a couple more. So start with the idea, step 1, that they are both in standard form. X, y on the same side for both equations. Step 1 is done. Do I have anything that either like term with opposite signs? So same number, opposite signs. And the answer is no. So then I need to create one by multiplying. So I'm going to multiply this by 10, because then my negative 10y and my positive 10y will cancel. So then I have the equation 12x minus 10y equals 18, negative 30x plus 10y equals 0. Combine my equations, that's negative 18x, those cancel, equals 18, x is negative 1. So then we have to substitute that back into the other equation. So 12 times negative 1 minus 10y equals 18. Negative 12 minus 10y equals 18. Add 12 to both sides. Negative 10y equals 30. Y is negative 3. So my solution should be the point negative 1, negative 3. Make sure that you put it in parentheses. If all you do is give me the x and the y values and you don't put it in parentheses, that will not be considered complete and you will not receive full credit. Okay, so now let's do our check. 12 times negative 1 minus 10 times negative 3 equals 18. Negative 3 times negative 1 plus negative 3 equals 0. So this is positive 3 minus 3 is 0. Check. This is negative 12 plus 30 is 18. Check. So I know that those are correct. You can simply enter this half into a calculator and make sure that you get 18. And then you could enter this half and make sure that you get 0, because both sides have to be the same. So this is, in fact, the solution to that set of equations. All right, our final example. Step 1 says put them in standard form, and they currently are not. So when I get them into standard form, I'm going to move the 2y to the other side, so I get 3x plus 2y equals 16. When I move the 5 to the other side, negative 5x plus 12y equals 4. So step 2 says that I need to multiply to make sure that I have same number, opposite sign coefficients. I think if I do the x's, then I have to multiply them both. But if I do the y's, I can make that 2 into a 12 by multiplying by negative 6. So that gives me negative 6x minus 12y equals negative 96. That comes from just multiplying. I'm going to rewrite the bottom equation, negative 5x plus 12y equals 4. When I combine them, negative 11x, my y's cancel, equals uh-oh, I missed something. This should be 18 because 6 times 3 is 18. Negative 23x equals negative 92. We would divide by negative 23. X is 4. So my solution is 4 something. And so I have to find the other coordinate by substitution. So then I'm going to substitute 4 into the other equation. So 12y equals 5 times 4 plus 4. 12y equals 24. Y is 2. So that's what I think my number is, but I need to check to verify. So then my check 3 times 4 equals 16 minus 2 times 2. 12 is the same thing as 16 minus 4. That's true. 12 times 2 equals 5 times 4 plus 4. 24 equals 20 plus 4. That's true. So now I've verified that my solution is actually a point on both lines by having checks in both places. So this is how you solve equations using the elimination method. Remember that you need both equations in standard form. You need to be able to eliminate one pair of opposite terms. And then we substitute back in to be able to find the answer. And we always check our work.